Alright, welcome back to the nightclub. Today we're doing lesson 7-1. Hopefully if you've been in any kind of algebra class, you remember this stuff. It says, understand polynomials. So, we're going to understand a polynomial.
Say that word.
So, a polynomial. It says, why does a constant have a degree of 0? So, first off, what is the degree of a polynomial? Do y'all remember?
186.
It's real simple, okay? If you take a monomial means what? One nomial, okay? All right? There's monomials, there's binomials, there's trinomials. Monomials have one term, binomials have two terms, trinomials have three terms, okay? Anything over 3, you just say 4-term polynomial, 5-term polynomial, 6-term polynomial, okay? The only ones that have names are monomial, binomial, and trinomial, okay? So, the degree, okay? The degree of a monomial is the sum of the exponents of the variables of the monomial, okay? So, a monomial, it's a number, has to be real, by the way. All your numbers that you deal with in here will be real numbers. There is something, just foreshadowing a little bit, there are some things called imaginary numbers that you'll get to in Algebra 2. Alright? So, but for Algebra 1, we only deal with real numbers, so it's a real number, a variable, or the product of a real number and a variable. So product means you what? Multiply. You can be multiplying. Okay? So it's either a number, a letter, or the product of a number and a letter. That is a monomial. Okay? The degree is the sum of the exponents of the monomial. So, example. The variable in the monomial 15x squared has an exponent of what? 2. So the degree is what? 2. Very simple. Okay? This one, the sum of the variable exponents in the monomial 1/2 x to the 5th y squared is what? Notice, we're not just going off the x, we're not just going off the y, we're going off of the one, them combined. Okay? So 5 and 2 make 7, so its degree is what? 7. Okay? Most of the time it's like here, where you just have one variable. Sometimes you have more than one. Any questions so far? All right? Here is why a constant, it doesn't have a variable, right? So here's why its degree is 0. Any number to the power of 0 is what? 1. So if you have 7, that's like saying 7 times x to the 0 power. Well, x to the 0 power is what? 1. And 7 times 1 is 7. So that's why anytime you have a constant, its degree is considered to be 0. Okay? By itself. Everybody understand that? All right. What if you just have x? What's its degree?
1.
1. It's not going to say x to the 1 power, but the 1 is there. Everybody got me? All right? Why is 5x to the 3rd minus 4 called a cubic binomial? Cubic is the 3rd power. That's the degree, right? What's the degree of this part? What's the degree of 5x to the 3rd? 3. What's the degree of negative 4? 0. Okay? Again, does negative 4 have a variable with it? No, so its degree is what? 0. All right? Correct. We mean the small numbers. Exponents. Yes. Okay? So, this entire thing has a degree of 3. You pick the biggest one. Okay? This is a term, and this is a term. Why are they not one term together? Because they're what in between them? You're subtracting. Remember, what's a monomial? A number, a variable, or the product of a number and a variable. We don't say anything about adding and subtracting, correct? So that's a monomial. 5x to the third is a monomial. -4 is a monomial. Put them together, how many monomials do you have? 2. So the entire thing is called a binomial. Everybody understanding that? Okay? So it's a cubic because of the degree. It's a binomial because of the number of terms. That's how you name polynomials. All right? So, down here, they gave us a few extra. 7 has a degree of what? 0, and it's just called a constant. 4x has a degree of what? 1. That's linear. Okay? You've done lines, right? 3x squared plus 2x plus 1. What's the degree? 2. So it is a quadratic. Okay? -5x squared y. That's 2. What does the y have? A 1, which is 3. So it is a cubic. Okay? And then last but not least, 4x squared y squared plus 5x minus 2y plus 6. 2 and 2 make 4. That just has 1. 2y just has 1. 6 has 0. You pick the biggest one, which was 4. And like I said, if it's anything over a cubic, this says 4th degree. They actually do have names for the degrees. That would be called a quartic. Okay? 5 would be a quintic, but for our purposes, we won't go above cubic.
Why is
Okay.
that quadratic for 2?
That's a great question, and I don't know the answer.
Because you would think it would 4, right?
You would think quad doesn't, like a quadriplegic means they, they can't move their hands or their arms.
Yeah.
Okay, their legs or their arms. All right. So I don't know. It's just it's a quadratic is 2, a quartic is 4, like a quart of milk. Okay. So polynomials with a degree greater than 3 are named by their degree: 4th degree, 5th degree, and so on. Okay. Degree. I can't talk. All right, so these are all naming by degrees. These are all the number of terms. How many terms? 1. 4x is 1 term. So it's a monomial. X plus 7 is how many terms? 2. X is a term. 7 is a term. I'm sorry? You're talking about the degrees. You name it 2 ways, by the degree and by the terms. Okay? Right now we're talking about the terms. Up here, we were talking about the degrees. Okay? So right now we're just counting how many terms it has. This has 1 term, 2 terms. So it's called a binomial. This one has 1, 2, 3 terms. Trinomial. Anything over 3, 1, 2, 3, 4, that's a 4-term polynomial. Okay? Everybody good so far? All right. Let's try some. It says name each polynomial based on its degree and number of terms. Okay? Degree usually comes first. So what's the degree of this? 3. Again, that x has a 1 with it. And you have to add them up. Okay? 1 and 2 make 3. So it is called a cubic. How many terms? 1. So it's a monomial. Cubic monomial. All right? What's this degree for B? 2. This one has 1. This one has 1. This one, though, has 1 and 1 make 2. All right? So it is a quadratic. How many terms? Trinomial. A quadratic trinomial. Everybody good? All right? It's very easy, yes.
We have like a chart with the words on the test.
Now, to write them in standard form. To write in standard form, it's very simple. You write them from the biggest degree down to the smallest degree. Okay? So, if you had one like this, what in there, first off, how many terms does it have?
What?
There's 5.
It's 5. Where'd you get 6?
5 terms. Okay.
Okay, well, I was just.
Which of those terms has the biggest degree?
6x to the 4th.
That's what you need to write down first. Which term has the next biggest degree? Negative x to the 3rd. What's my next biggest?
Negative 3x to the 2nd.
My next biggest?
7x.
And finally, my constant is?
Negative 5.
That is standard form.
Wait, I don't like
That's actually.
I'm gonna forget.
Sorry? Correct. You put them in greatest exponent to smallest exponent. Okay? Not coefficients. Coefficients have nothing to do with it. It's always biggest exponent down to the smallest. Okay? We ain't worried about this. We're not worried about that coefficients. It's all about exponents. 4, 3, 2, 1. That one has an exponent of 0. Okay? Because remember, it's x to the 0, which makes it go away because it's just 1. All right? So, how would we write this one? What would come first? Negative 3x to the 3rd plus 6x squared plus 7. If I asked you to name it, what would the name be? And?
Cubic trinomial.
Say cubic trinomial. Okay? The degree is cubic. There are 3 monomials. So it's a trinomial. Everybody good? All right. How about this one? What are we gonna write first?
Negative 8y.
Negative 8y squared. Then what? Plus 2y. That is standard form. Okay? What's that name? It's not a cubic.
Binomial.
It's not a binomial.
No, I mean it's a.
It's a
What's it called?
quadratic
Quadratic. Trinomial.
trinomial. Okay? Quadratic trinomial. Everybody good? It's just the name of it. I can't tell you. I know realize quad sounds like 4. It's not 4, it's 2. The exponent of 2 is called a quadratic. Okay? All right. It is weird. All right. Adding and subtracting monomials. This is your basic. Y'all have heard of adding like terms?
Yes.
Okay. To be a like term, it has to have the same degree and same variable. Okay? So you cannot add x squared plus x. They're not the same degree. Okay? You can't add x squared plus y squared. They're not the same variable. Okay? You can add x squared plus x squared is what?
2x squared.
2x squared. Okay? Think of it like you're counting apples. 3 apples and 4 apples make how many apples? 7 apples. One like this. How many x squareds do I have here? 3. How many's there? 3x squared plus 1x squared equals 4x squared. Okay? Now, you do not add the exponents because do you, when you add those apples, do you say 7 apples squared? No, because they're still just what? They're still just apples. These are still just x squared because all we're doing is what with them? Adding them up. How many do I have here? I got 3. How many do I have there? I got 1. So, how many do I have? How many x squareds do I have? 4. So 4x squared. Does that make sense? Okay? So, that will be 4x squared How many x's are there? 4. How many x's are there? 2. How many x's do I have? I have 6 x's plus 5. Okay? That's all there is to it. You're adding your like terms. Any questions? Easy enough?
That's the first thing that makes sense on you.
How many x's do I have here? There's 4. How many are here? 4 plus 2 is how many x's? 6x. That's where the x comes from. Okay? Yes, ma'am.
We have to solve for it.
You will. Don't rush it. You'll have plenty of time to solve for x. Okay? Plenty of time.
Is it the same lesson?
We'll get there. Now, you have a few choices. Some people, let me go back. Let me see, can I go back? I can't go back that way. Some people like to do this. I should have showed you this. I think they show you this. I'm looking. Where is it? Oh, I didn't show it to you. Here we go. Yes, okay. I'll just show you with this one. Okay. Y'all listen, we're almost done. Some people add horizontally and some people add vertically. I'm in the wrong example again, I'm sorry. So how we just did that last problem, okay? Some people add vertically, some people add horizontally. This is what I mean. We added horizontally, okay? But you can add vertically. You can just take this right here and move it down here. And take this 2x and move it down here, okay? Those go away, and now you're adding vertically. Just like you used to, you know how you can do 4 plus 5 is 9? Or you can do 4 plus 5 is 9, right? It does not matter which way you want to do it. Some people like this way because they get to add, they get to line up all their like terms, and it makes more sense to them. They don't miss any. Does that make sense? Okay, like so. Some people can do it horizontally. Some people can do it vertically. Doesn't matter to me which way you do it. All right. We get the same answer either way. All right. It says, how is adding polynomials like adding whole numbers? How is it the same? How do you add whole numbers? You just add the numbers, right? How is adding polynomials the same way? You're adding the numbers that are in front of the variables, the x's. X squared, y squared, whatever it may be. So that part's the same. The only difference is what you're naming, what you're adding. A minute ago, we were adding x squareds. We were adding x's. So you're figuring out how many of those you have rather than just how many numbers you have. Okay? So there we go. Just what I just got finished saying. This is like doing it vertically. You can also do it, your polynomials vertically. Okay? Or you can go horizontally. It doesn't matter. Just make sure you don't add something that's not the same. Everybody with me? Okay? All right. Last example. Now, lots of teachers do this different ways. This is how I do it. I am a big fan in just adding. I like adding more than I like subtracting. Y'all kind of the same way? Okay? So, when I get a subtraction problem, I make it into an addition problem. Okay? I want you to understand what this is. It says minus, right? But what's actually out in front of this parentheses? It's a -1. So you can distribute that -1. When you distribute it, all the signs in here do what? change. So, as a kind of a quick way of doing that, I can just change this to a plus sign and change all the signs behind it to opposite of whatever they are. So this now becomes negative, negative, positive. Now it's a what kind of problem? An addition problem, okay? You can add it horizontally like I'm about to do, or if you wanted to move all these under here and add it vertically, you can do it that way too, okay? How many x squareds are here? 6 of them. How many are here? What kind of 3? Negative 3. So 6 minus 3 is 3x squared. 3x minus 5x would be negative 2x, negative 2 plus 8, positive 6. We just subtracted. That makes sense. It's very easy. Again, you've done this for a long time. They just called it adding like terms. That's all this is, that you understand that x squared and x are not alike. They have the same variable, but they're different, okay? This is an x squared, this is an x. You can add them, but you can't physically add them unless you know what the x's are. That makes sense? All right, let's do one more. And we will call it a day. Here, that will be, again, change that to a what? Plus, plus, minus. Okay? Understand, only change what's in the parentheses behind it. If we had something like minus 9 on the outside over here, you wouldn't change that because it's not in the parentheses in front of the negative. Is everybody with me? So, I'm going to line them up vertically this time. So I got a plus x and a minus 4. If I add them up, 3x squared plus 5x minus 2. Boom, bada boom. All right? Y'all have a great day. Stay above the line as always. See you next time.